This is a solution video for Algebra 3 inequalities. It's exercise 12.1, page 459, question 12. And it says that n is between a and b, and 2 to the power of n is between 100 and 200. And they want us to figure out what a and b might be and what n would be. Now, the n will be a specific value because they're saying that n is an element of the natural number set. And they're also saying that a and b are elements of R. So what we're really going to do first of all is have a look at the n. So what whole number for n would allow us to land between 100 and 200? So I suppose what you could do is you could start listing out all your powers of 2, like this. And we can see that we're starting off with 2 to the power of 0, and then we've got 2 to the power of 6. I'm kind of just skipping over these. 2 to the power of 7, 2 to the power of 8. And the only one that lands between 100 and 200 is obviously 128, so that's 2 to the power of 7. So if that's the only power of 2 that lands me in that required range, then n is going to have to be 7. Now, I'm not thrilled with the way this question is phrased, to be honest with you, because they're just saying that a and b are real numbers and n is between them. So really, you could pick any two real numbers that are either side of 7, and that's kind of fulfilling the criteria of the question. But I think what they're really getting at is, if n didn't have to be a natural number, what's the lowest I could go with that power? And what's the highest I could go with that power so that I'd still stay between 100 and 200? So obviously, it'll have to be bigger than 6 and smaller than 8. And 6 is actually too small because that brings me down below the 100, and 8 is actually too big, so that brings me up over the 200. So it'll even be somewhere for the first value a, somewhere between 6 and 7, and for the second value b, somewhere between 7 and 8. But let's just see if we can be more specific than that. So I'm going to first of all go back to my inequality that starts this off, and I'm going to split it into two separate inequalities, and I'll write them out separately. And so I'd have 100 has to be less than 2 to the n, and 2 to the n has to be less than 200. And I'm actually going to, because this is kind of the gist really of what they want in the question, I'm going to call this value, this power a, and I'm going to call this power b, because they're really talking about what's the lowest possible power to get over 100 and what's the biggest possible power that will keep me still underneath 200. And I don't really like dealing with inequalities where the unknown is on the right hand side, so I'm going to actually take this whole inequality and write it the other way around, from right to left, so that it reads 2 to the power of a is greater than 100. And it's totally fine to do this because you can see that I'm actually writing the same statement down. You can see here how the wider side of the inequality symbol is on the 2a side of this inequality, and I've kept that in my second version. So actually this is the same statement as this, just read from right to left. Okay, so I've got a statement 2 to the a is greater than 100, and I've got a statement as well 2 to the b is less than 200, and I want to figure out what the a and the b are. Now, at this stage in the chapter, we don't actually have the tools to go about calculating this properly, so you could just start sticking in values that are bigger than 6 until you find a value that brings you up over the 100. And you could do the same at the other end and just start sticking in values of b that are between 7 and 8 until you get just before 200. But since I'm going through the solutions, I'll show you how to do it using logs. And this is something we'll encounter a little bit later down the road in this chapter. So you can see how my unknowns in both cases here are in the exponent. And if I have an unknown value in an exponent, I can use logs to get in at it. So logs is just a variation on indices, basically. So I can apply logs to both sides of my inequality in the same way that I'd be able to square both sides or add 2 to both sides or something like that. So what I'm going to do for this one over here is I'm going to rewrite it as log to the base 2 of 2a. And then on the right hand side of that inequality, I'll write in log to the base 2 of 100. Now what a log means is, for example, log to the base 2 of 100. This basically means what power can I put on 2 to get to 100? And if I ignore the a for a second here on the left hand side, it's what power can I put on 2 to get 2? Okay, so obviously the power that I put on 2 to get a result of 2 was 1, and we'll see that in a second. And there's a rule of logs that lets me take the power within a log and bring it down in front. And it's the a that I want to work out, so I have to get the a by itself. So I'm going to take the log base 2 of 2 and bring it over here, and I'm going to divide it into log base 2 of 100. And I said a second ago that this is actually working out as 1, so I know it's a positive number, so I have no problem bringing it across and dividing it. So we can actually use our calculator now to work out the value of a. So if we go to our calculator, so this is making me use a fraction, so I press the fraction button. I hope you can see that screen. And then on the top, I want to type in log base 2 of 100. So I'm going to press this log button up here on the top right hand corner, and I can put the log value in. So it's base 2 and it's 100. And then on the bottom, I also want to put in a log, so log base 2 of 2, and then I just press equals and I get an answer. So in this case, it's 6.64385. I'm going to round that off a little bit to 6.644. And I'm just going to double check, if I was to go back to this line here, 2 to the power of a is greater than 100. If I put that power, can't see it. If I put that power in, would I get a result that was bigger than 100? So I'll go to my calculator and I'll type in 2 to the power of 6.644 equals, and I get 100.0099687. So yeah, I'm just over the 100. So any value of a that's bigger than this will bring me in over the 100 that I want. And now I'll do the exact same thing here with this. So I've got log to the base 2 to the power of b less than log to the base 2 of 200. Now I've just picked log to the base 2 here, to be honest with you, because the base that I had in my original index, in my original exponential term, if you like, was 2. But actually with the modern calculators, you can use whatever base you want. I'm just doing that because I'm coming from an era where you couldn't necessarily work it out as easily as that. So yeah, whatever base you want, log to the base 2 is what I'm going to go with. But if you use log to the base 37, the calculator will still work it out for you as long as it's the same log base on both sides. Anyway, so same idea. So the rules of logs allow me to put the power in front, and there's a whole page in the log tables just right next to indices actually for rules of logs, and we'll see those a little bit later on. So I can put my b in front. B log to the base 2 of 2 is less than log to the base 2 of 200. I want to get the b by itself. I'll bring the log to the base 2 across, and then I'll go to my calculator again and I'll work it out. So on the calculator, I'm typing in on the top log to the base 2 200, again using this log button up here, over log to the base 2 of 2, and I hit equals, and it gives me 7.6438561.9. So b has to be less than that. Now, just be careful when you're rounding off here. It's really tempting to write down 7.644 as your answer, but if I have to be under this value, if I round up to 7.644, I've gone over it because that's actually a bigger value. So I'm going to round this to 7.643. I actually round it down. And once I've got that value, I'm just going to double check what would happen if I put that as a power on 2. So I've got 2 to the power of 7.643 equals 199.88. Yeah, it's bringing me in just underneath the 200. Just as a matter of curiosity, if I had rounded up to 7.644, let's just see what would have happened. In that case, I would have gotten 2 to the power of 7.644. And that brings me in at 200.0199. So actually I'm over the 200 there, and I don't want that to happen. So they were asking me in the original question for a and b where n had to be between these two values. So I'm going to write that now as n having to be between those. But I know that n has to be 7 because they specified in the question that n had to be a natural number. Like I said, not the best worded question in the world, but that's what they're going for. They want to know what the lower limit of n would have to be if n didn't have to be a natural number, and what the upper limit of n could be. That's your b value if n wasn't required to be that natural number. And like I said, there's a bit of logs in there. We haven't done logs yet. We will come across them in the future. There is a section in the log tables next to indices on them. Don't worry about it. It'll be September before we look at those. But it's just nice to know how to go about that without having just to use guesswork.